So climate and weather are terms that are often used fairly interchangeably just in the general conversation, but they do mean two very different things. So the weather is what it is right now outside. Right now it's bright and sunny outside. That's the weather. So weather is a snapshot of what's going on right now or today, whereas climate is long term. So it's the average weather patterns for an area over a long period of time, anywhere from 30 to a million years. And climate is determined primarily from two things: precipitation and temperature. Those are the two main things that are looked at when we're talking about climate. And those two things are going to be influenced by the latitude, that's the lines going around the globe, not up and down, but around horizontally. So the latitude, whether you're at the equator or closer to the poles. Altitude, how high you are, like up a mountain. Ocean currents, we'll look at how that can impact precipitation and temperature. And then those all affect where people live, how people live, and what we grow and eat. So it determines, and it's not just people, it determines where all living things live. So I said that latitude is one of the things that influences climate, and part of that is because of the curvature of Earth as well as the tilt of Earth on its axis. It's a 23.5 degree tilt, and that affects the angle at which solar radiation strikes Earth at the different latitudes. So it's what gives us our seasons. So when the northern hemisphere, where we are, is tilted away from the sun, that would be our winter, and that would be summer for the southern hemisphere. When we are tilted, when the northern hemisphere is tilted towards the sun, then that is our summer, and the southern hemisphere's winter. So it is that tilt that gives us the seasons, but what gives you the different temperatures at the different latitudes is partially due to the angle at which the sun strikes the Earth. If it's a direct angle, like at the equator, you're getting a more intense solar radiation, whereas at the poles, it's a less direct angle. It's a oblique angle, and so you're not getting as direct as striking of the solar radiation, and so it's cooler because of that. So the Coriolis effect is due to the fact that Earth is curved and it's spinning on its axis. So it's spinning so that a point on the equator would be traveling at around 1,100 kilometers per hour, but point at the poles are not moved by that rotation. So what that means is there's a deflection of the movement of objects due to that rotation. And so since wind is just made up of molecules of air, those are going to be affected by the Coriolis effect. So winds are primarily driven by solar heating. And if it were just literally for the curvature of the Earth and solar heating, then we would expect the prevailing winds to move either from the north or the south, depending on the latitude. But what we actually see is that the winds flow either to the right in the northern hemisphere or to the left in the southern hemisphere, and kind of in a curved pattern based on a combination of the heating and the deflection as Earth spins. And so you might have noticed this in terms of weather. We're affected by the westerlies. So most of our weather patterns travel through the state of Georgia in a northeastern direction. They're coming from the west. So most of our weather comes from the west. Occasionally there are exceptions to that because of other weather events going on, but as a general rule, our weather comes from the west and it moves in that northeastern direction due to the Coriolis effect. So another thing that affects climate is the properties of air, water, and land and how that affects global air circulation. So in the picture here, you can see, just based on what you know about hot air rises, right? So we've got hot, wet air over here, and it rises and goes up into the atmosphere where it cools and condenses and comes back as precipitation. And then in a low pressure area, that cool air is going to fall to the ground where it's going to warm up again and rise again. So it's this constant cycling. You get this kind of cycling of the air as it heats and rises and then cools and falls, and heats and rises and cools and falls continuously, and that creates these circular currents. So then what we see globally with these circular currents is there are 6 giant convection cells at different latitudes that actually determine the location of the biomes. So you'll notice that everywhere that you see one of these circular convection currents is another biome, and that's because of the types of weather patterns that occur due to those convection currents. All right, so let's talk about the greenhouse effect. The greenhouse effect is a good thing. Without the greenhouse effect, we would not be able to live here on Earth. It would not be at a sustainable temperature for life. So we have greenhouse gases in the atmosphere, including water vapor, carbon dioxide, methane, nitrous oxide, and some other in more minor amounts. And what these greenhouse gases do is they trap some of the infrared radiation, ultraviolet radiation. A lot of it will pass back out into space, but some of it does get trapped here on Earth, and that is what allows us to maintain a livable temperature. Just like a greenhouse can keep temperatures at a sustainable level for plants to grow during the winter, so you can grow things out of season in a greenhouse. So obviously the concern, which we'll talk about more later, is as we increase the amount of greenhouse gases in the atmosphere, we're trapping more and more heat. But generally speaking, the greenhouse effect, as it exists, as it's intended to work, is what keeps the temperature at a life-sustainable level here on Earth. So topography, the lay of the land, so to speak, can have a tremendous impact on weather as well, or climate more specifically. So places where you wouldn't normally, for example, have a desert, you might have a desert because of the topography in the surrounding area. So we get something called a rain shadow effect desert on the leeward side of a mountain range. So as it shows here in the picture, you've got water coming in from the Pacific Ocean, and you've got this mountain range. And the mountain range actually kind of blocks the clouds on the windward side of the mountain range, and so the precipitation falls on that side. And then what you get on the other side, on the leeward side of the mountain, then is a dry desert habitat, because all of the moisture is over here on the windward side. So that is a rain shadow desert, where you wouldn't necessarily normally have a desert due to the other, the convection currents and other factors that determine the location of deserts. So I really like this picture that's found on page 107 in your textbook, because it shows the relationship between temperature and precipitation as far as the type of biome that you would find. So if you have hot and wet, you're in a rainforest. If you have hot and dry, you're in a tropical desert. If it's kind of a mid-range temperature and fairly wet, you have a deciduous forest. But those mid-range temperatures and a little drier, you might have grasslands. And then all the way at the top, if it's cold and not a whole heck of a lot of rain, you're going to be in the tundra. So it's a good overall comparison looking at the connection between temperature and precipitation and the type of biome that can be found there. You can also see a difference in biome distribution based on elevation and latitude. Lower elevations will be your forests, upper elevations would be your tundra and mountain ice and snow. As you move from the equator to the poles, you again go from forests to tundra to polar ice and snow. So elevation and latitude also affect biome distribution.